Now we are going to see a topic, non-deterministic finite automata. So this is one type in finite automata. So then normally the finite automata having two types. One is deterministic finite automata, and one is non-deterministic finite automata. So the non-deterministic finite automata is easy to construct than deterministic finite automata. So now we are going to see about non-deterministic finite automata. So what is non-deterministic finite automata? So it can be simply defined by using five tuple format. So what are things are there? Five tuple. So one is Q, another one is sigma, delta, Q naught, F. So these are the five tuple format for NFA. What is capital Q? Capital Q is a finite set of states. It is a finite set of states that is represented as Q. Next one is sigma. That is an input symbol. Yeah. So which is defined as a finite set of input symbols. Next one is transition. A transition, it is represented by the symbol. This is the symbol representing transition. So this is one type of symbol. So different persons may use different symbol to represent transitions. So for general, this is general representation. So we are taking number of states. For those states, if you are applying input symbol, we are getting, so one of the states of 2 power q, one of the states in 2 power q. So next one is initial state or start state. It is also called as a start state, that is represented by q naught. This is also belongs to q, that means one of the state q naught is one of the state of q. So the last one is final state. F is a final state. So it is a set of states or set of final state. Generally we can represent it as an F. That is also belongs to Q. So these are the five tuple format for non-deterministic finite automata. Next we are going to see an example for non-deterministic finite automata. So non-deterministic finite automata. For example, we are taking an input symbol A. Taking input symbol A. Q naught. This is some of the states. From a state Q naught, this state is Q naught is the starting state here. From Q naught, for an input symbol A, if there is more than one transition, then it is called non-deterministic finite automata. So on the other hand, from a state for an input symbol, if there is only one transition, so that is deterministic finite automata. There is a difference between NFA and DFA. So again I am telling, for NFA from a state Q naught for an input symbol, so there is only one move. This is DFA. So now for NFA from a state, more than one state moves are possible. This is NFA. For example, Q, from Q naught, not Q naught, this is one transition. From Q naught to Q1, there is one transition. From the same state Q naught, one more transition may be possible. From Q naught to Q3. So any transition may be happen. So many possible transitions are happen. So any one transition can be chosen. Depends upon your choice. So the same thing, there are two choices. So if you're choosing this choice, so we will reach the final state. If you're choosing this choice, we are not able to reach final state. For example, there are two input symbols. We are taking two input symbols from Q naught. So which type I can choose, or which path, or which transition I can choose, or which move. This is one move. From Q naught, after reading input symbol A, I may reach to Q1. The next, one more symbol. One more next symbol is A. From Q1, after reading A, I can move Q2. So now I have reached accept. So this is a non-deterministic finite automata which accept a string A. Which accept a string A. So for the same input symbol. So already I have chosen, this is the path I have chosen. In case instead of that, in the first move, instead of this path, if I am choosing this one, what is going to be happen? Now see what is going to be happen here. From Q0, they are moving to Q3. From Q3, there is no transition for further. From Q3, no further transition. So what is going to happen? So this path is not a correct path. We need to try some other path. If it is available, already we have chosen that path. If you are using this path, only we will reach the final state. If you are using this path, we are unable to reach final state. Same thing. Some example. Something which path we are choosing. You can choose any one of the path, but if you are not able to reach final state, try to use some other path. Through that path, we may be reach final state. So anyway, if you reaches the final state, then only the given string is accepted by designer. Otherwise, that is not accepted.